I was doomed as soon as I said it. Maybe just an easy project to catch my breath a bit. Something I've been needing for a while, like a tab follower. It's just a couple simple parts, entirely lathe work, my favorite, and no crazy features outside my comfort zone. This should be a piece of cake. Little did I know, I was about to learn the biggest lesson of all. Never, ever get complacent. The general idea behind a tap follower is pretty straightforward. It's a tool with a center point for aligning taps to keep them straight in the hole you're trying to feed them into. And the follower is backed by a spring to keep the point engaged as the tap travels deeper into the hole. Most taps over a certain size have center holes drilled on their ends exactly for this reason. Then everything smaller is ground to a center point like this. And when that's the case, I just use a T-handle wrench that includes a center hole on the back. Pretty straightforward. But even with such a basic principle, there's a lot of ways this build could go. I can envision using this tap follower in a variety of situations on both my mill and the lathe. So I wanted to be prepared for anything I throw at it. That means it needs to be compatible with a lot of different tooling, including different chucks, collets, and Morse tapers across both machines. Is this overkill? Maybe, but I like options. Next is how I'll actually make this thing. I'm going to do my best to design this around both materials and tooling I already have on hand. I'm sure I have enough raw material, but the spring may be a bit tricky. I hope I have one that will work. Fortunately, my grandfather had a tendency to hang on to everything, so I have some options. Even though I basically have all the dimensions and tooling selected, I still prefer to put together a detailed design, just so I'm not fleshing things out on the fly. Trust me, I've done that, and it usually doesn't end well. To start, I need a body. This will include a straight shank portion at 5/8 inch diameter, which is the largest I can fit in either the mill or the lathe drill chucks. And this will also make it mountable in a mill collet for when I need a low profile option. On the other end, I'll also include a size 3 Morse taper. This won't be a full length taper, but should give about an inch of engagement to properly lock the tapers together, keeping everything straight and on center. This single taper feature gives me the ability to mount either right to the lathe tailstock, in this R8 adapter for the mill, or if I'm feeling frisky, in this tool post holder. Not sure why I would need that, but it's an option, and I like options. Now for the inside. This is pretty simple with just 2 concentric reamed holes for the plunger. But I'm leaving the main plunger contact area at the front fairly long. This should provide both lateral and angular support to the plunger, keeping it on center and at a lower risk of wearing. The back end then gets a simple thread for a cap to contain everything within the body. The plunger is basically a 2 diameter pin to match the 2 diameters inside the body, but I'm going to aim for very tight tolerances on these dimensions so that the fit is smooth and accurate. The leading end of the plunger gets a 60-degree point to match the standard center holes on taps and tap wrenches, and the back end will get a little step pin just to help center the spring in the body. The last piece is the threaded cap, which of course includes threads to match the body, a step pin to again center the spring, a slightly rounded end to help with the Morse taper drift tool, and being that this is my first project since finishing the knurling tool, I can't resist including a nice knurl on this part as well. Alright, that should just about do it. I'll drop some dimensions on here and I can get to work. I'm going to start with the body since I have the most tooling constraints with the different reamers and taps. Doing these first means I can fine tune the other pieces later to fit just right. I'll grip this stock close to the end for a quick facing and center drilling operation, then slide it out enough to form the whole part from, and bring in the live center for support. Now the features I'm about to turn need to be dead straight, meaning there can be no unexpected taper in the diameters. So I need to verify my tailstock is in a good position and not deflecting the end of the bar one way or the other. To do this, I'll take a skim pass along the part and check the dimensions at each end. Looks like 4 thou larger on the tailstock end. I'll need to adjust the tailstock toward the front of the machine 2 thou to make up for this difference. Using my tenths indicator, I can get squared and zeroed up on the tailstock quill, then loosen the locking bolts and make the slight adjustment. Then lock it all back down and take another skim pass. Well, it would help if I adjusted it the right way. Let's try that again. After actually going the right way, as well as a couple more finer adjustments, this is looking a lot better. I'm hitting within a 10,000th along the length. I'm going to call that good. Despite my previous best efforts, my lathe is slightly out of alignment, so the adjustment I just made is limited to this exact tailstock position on the ways. I'll save myself a lot of hassle later and preemptively mark this location. With the outside diameter turned down, I can start forming the 5/8 diameter section from the design. First hogging out the material with 40 thou passes, then switching to a finer feed for the lighter finishing passes. Sometimes when I have a shoulder like this, I like to cut the shoulder to length, then feed along the diameter away from the chuck to give a nice clean corner. It's not the optimum direction for this tool geometry, but the finish comes out pretty good despite that. Now to work on the Morse taper feature. This is a very shallow and precise angle, so I'll need to take my time dialing in the compound rest. If I'm too far off the specified angles, the tapers won't lock properly and the feature will be pretty useless. I'll mount the indicator arm in the compound and rest the plunger against the tailstock quill, so that as I sweep the compound, I get a change in the dial. For the 1.4377 degree angle, I'm expecting a change of 25 thou for 1 inch of travel of the compound. I'll tap everything into position until I'm spot on and lock everything down. Then use the tailstock quill to realign the tool post back square with the lathe. I'm almost ready to cut the taper, but first I need to scribe the stopping point. To mark it at a somewhat accurate distance, I'll center up the sharp thread cutting tool on the end. Then bring it in to the correct dimension using the DRO as a guide, and just lightly scribe the surface. Okay, now to actually cut this taper, which is basically just running the compound rest along the diameter, bringing the x-axis in a few thou with each pass until I reach the scribe line. But before I get too far, I'd better actually test the angle fitment with a piece of Morse taper tooling. It locks perfectly, but something isn't quite right. It looks like the end is already near bottoming out, and I haven't even cut the full taper. Almost like my starting diameter is too small. I followed the spec online, unless I'm missing something. Oh, I see where I went wrong. That dimension is the major engagement diameter, not the max diameter of the tooling like I was thinking. What a bonehead assumption to make. I even had the tooling that I could have measured. I suppose I could try to make this work, but seeing as I'm not that far along and everything is already dialed in, I'll update my print and just start over. Okay, with the correct dimensions, everything seems to be coming out as expected. The fit is perfect, and after a little smoothing out, I'm ready to move on to the bore. Normally to drill and ream holes I use the tailstock, but I'm actually curious to try out this drill tool holder I showed earlier. The only downside of this thing is it needs to be aligned. I know I'm already square from my setup earlier, but I still have the up-down and left-right positions to adjust to get it on center with the lathe spindle. So to do this, I'm going to use this Morse taper center. But I'm not just going to eyeball the alignment like you might expect. I'll get it close, then mount a dial indicator on the carriage and zero it on the end of the material. Then with the tool post unlocked so that the holder is free to move up and down, bring it in so that the holder floats to the right height and lock the tool post. Then adjust the x-axis in and out until the dial indicator again reads 0, both when the center is engaged and disengaged. I'll zero the DRO, then as a sanity check confirm the y-axis with the indicator as well, before locking down the tool holder nut. With all that dialed in, it's time to drill. This end is already center drilled, so I can just go right to my drill diameter and use the carriage hand wheel to feed the drill in. It takes a surprising amount of force on the hand wheel to feed a drill this large, but it does make backing out to clear the chips super speedy compared to the tailstock. And I'll have DRO precision for stopping at the correct depth. Ooh, that didn't sound good. Brilliant. That was a perfectly good drill. If I had to guess what went wrong, it's that I used this coolant rather than my normal cutting fluid. And apparently lubrication is more important than cooling when drilling. I suppose I knew that in the back of my mind, but now I'll never forget. Especially considering that, along with the busted drill bit, I also don't have enough length to properly salvage this part. So I'm left with no choice but to start over. Again. I'm burning through my stock, so the only tool steel I have left of a reasonable diameter is this 01 bar. Which of course is too large for my 5C collets, so I'll have to jump up to the 3-jaw chuck. And I'll have to adjust the tailstock yet again for the new position on the lathe bed. But even with this extra work, I'm able to get back to the pre-drilled state in short time. Rather than spend a bunch more time centering up the drill holder from before, I'll stick with the tried and true tailstock chuck. And of course, use actual cutting fluid this time. With the larger hole drilled to depth, I'll switch to a smaller drill to pick up where the larger left off. My thinking is that the point left at the bottom of the hole from the first drill will help center this smaller one. It's important, after all, that these are not just concentric with the outside of the holder, but also with each other. The two holes are still undersized from their final diameters, so I'll put a light starting chamfer on this bore, then bring in the appropriate reamers for each, taking them to the final diameter. The last step from this end is to tap the hole for the cap. This isn't a proper tap for power feeding, so I'll just get it started straight with a few turns in the tailstock chuck, then switch to the tap wrench to take it to depth. This would be the perfect situation for a tap follower. How ironic. That takes care of everything I can do from this end, so I'll part this off and finish the other side. I'll switch back to the collet chuck to mount this part by the 5/8 shaft, then face the last end to length, and naturally drop a chamfer on here. Finally, after 3 attempts, the body is complete. That was a bit more than I bargained for, and on such a simple part. I guess that's what I get for getting complacent. I can't let that happen on this next one. The plunger has a pointed end and a series of diameters. And it's important that these not only be tight tolerance, but also concentric so that it rides smoothly within the body. First step, of course, is to face and center drill the end in preparation for a live center, which is going to be critical for achieving the accuracy I mentioned earlier. And because I've since adjusted the tailstock, I need to realign this as well. But fortunately I get lucky and dial it back within a 10,000th on the first try. From here I can take a few more skim passes on the diameter until it's a perfect fit in the reamed hole of the body. So far so good. Next I'll start hogging away the material that forms the tip and sticks out the end of the body. As I get closer and closer to the final diameter, I take lighter and lighter passes in the neighborhood of 1 to 2 thou. This ensures that the material and tool deflection are minimal and aren't affecting my measurements as I home in on the final diameter until it's a perfect fit. And better yet, it looks like the holes on the body came out concentric as well. But there's something that's concerning me. You see that wobbling as I spin the body? Yeah, that's not good. I expected maybe a thou or so of eccentricity, but that looks like a lot more. Oh wow, that's over 10 thou. That can only mean one thing. The hole in the body drifted off center as I was drilling it. And I think I know exactly what happened. Reflecting back on it, there was a slight wobble to the part before I started drilling it. I'm not sure where this wobble came from since I had just machined these diameters. Maybe it was stress relieving of the bar as I removed the material. In any case, I did what I shouldn't have and ignored this issue thinking the drill would find the center. But I didn't consider that the deflection of the drill right from the start would actually send it even further off center the deeper it went. And that's exactly what happened here. So now this attempt is scrapped as well. This just goes to show you can't ignore anything when machining. I've got a better approach for remachining this, but first I'll finish up what I was doing on the plunger. First forming the spring centering pin on the back end, cutting the 45-degree taper on the front shoulder, and finally parting this off. I still have the 60-degree taper to tackle on the other end, but while I still have the compound rest dialed in for that Morse taper angle, I'm going to take my fourth and hopefully last attempt at the body. This time around, I'm using a simple hot-rolled low-carbon steel in hopes that there won't be any significant internal stresses relieving that could warp the part. It also has the advantage of fitting in the collet chuck, which saves me yet another tailstock adjustment. With all that turned down and the part looking straight, I'll start drilling. First with a relatively small drill, then jumping up to one a bit larger, though still smaller than the final diameter. Now the drill may still have wandered around a bit at the bottom, so to guarantee that the final diameter stays concentric with the outside, I'm going to use a boring bar. And it looks like it should be just small enough to actually fit in this bore. Well, maybe not. Once it's all the way in, it starts to rub on the backside. This is literally the only boring bar I have that's both small enough and long enough to do the job. So I'm going to have to turn this shank down just slightly to fit inside the bore. It's been a minute since I've had a proper side project. With the lathe all tied up with the part though, I'm going to have to use my other lathe. You know, the big blue one standing up on its end looking all lonely in the corner. Should be perfect for a small job like this. It has a fancy multi-directional tool holder for orienting the cutter however I like. Plus, with a continuously variable speed spindle, I can dial in on the speeds and feeds just right. All this makes turning down the diameter of the stem by 20 thou a piece of cake. Ignoring where I accidentally fed the tool in the wrong direction, this thing is ready for another stab at boring the hole. I'll get the insert mounted and reposition this back in the lathe and give it a whirl. It's still pretty tight, but clearance is clearance. I'm already very close to the final diameter, so I'll just take this a half a thou at a time until it's a perfect fit for the plunger. I'll finish this side by first tapping the bore for the cap, and then parting this off. I still have the other end and bore to take care of, so I'll get this mounted in the lathe, and face and chamfer the end like attempt number 3. Then start work on the bore, first spot drilling the end, then jumping to an undersized drill to form the starting bore. I'll switch to this even smaller boring bar, which fortunately doesn't require another trip to the vertical lathe, so I can again open this bore up little by little until it's a perfect fit for the stem of the plunger. Alright, now for the moment of truth. Finally, after 4 tries, I've successfully made the body. That was definitely more tricky than I ever thought it could be, but I can't let my guard down just yet. To finish the plunger, I still need to turn the 60-degree taper. The taper is far out on the end, so to make sure I'm supporting the material as close as possible to that end, I'll drop the stem through the back of the collet before mounting it in the lathe. With the Morse taper cutting behind me, I'll adjust the compound rest to 30 degrees, cut off the excess length I left for the center drilled end, then begin forming the taper running the lathe in reverse. After a light shining up with some emery cloth, the plunger is complete. That just leaves one last and final part to make, the cap. This is a short enough piece that I should be able to get away without any tailstock support for a change. So I'll face the end clean and begin turning down the diameter. This will get knurling, so I'll need to take it to a specific dimension. And to figure out what that dimension is, I'll use an online knurling calculator. It looks like the nearest smaller diameter that will work for the pitch of my knurling wheel is 0.618. So my starting diameter needs to be 0.608. I'll finish turning down the stock to this diameter, then bring in the knurling tool for its first real job since making it. I'll get everything centered up and adjusted in, turn on the spindle, then engage the wheels and the power feed, and let this thing work its magic across the part. That will do nicely. Next are a few quick operations to prepare the end for some threads. First turning down the diameter to 9/16 where the threads will go, then clearing the thread runout area, and lastly turning the spring locating pin on the end. Now to cut the threads. I'll get the pitch dialed in on the gearbox, set the compound rest at 60 degrees, take a light scratch pass to confirm the pitch is correct, then begin taking successively deeper cuts, forming the threads until they're a perfect fit for the body. And once they are, I'll part this off to length. This just leaves the final end to take care of, which gets a large radius turned on it. I have this form tool from a previous project that should do the trick. I'll just have to mount it upside down to get the cutting edge on the correct side. So I'll get this set up in a tool holder, and just for a little extra support, stack another tool blank on top of it. Then after centering the tool on center line, I can run the lathe in reverse and slowly bring the cutter in to form the radius. A little polishing with emery cloth and the cap is finished. And that's actually everything complete. Nothing left to do but to put it all together and test it out. Very nice. There's a bit of preload on the spring, so the plunger isn't all loosey-goosey on the end of its stroke. And the fit of the plunger seems fairly tight in the body, so should do well to keep the tap centered. Actually, let's see how it performs. First on the mill. I've got a hole pre-drilled here, so I'll get the follower mounted in a collet, then place the tap in the hole and bring the follower down, preloading the spring and locking the quill. And tapping is like a dream. The tap follower follows the tap just like the name suggests, and it has no problem staying engaged and keeping everything straight. Let's try this over on the lathe. I'll get this mounted in a Morse taper adapter, and then place that in the tailstock. Add a bit of preload, and yep, it works just as great here. This is going to make tapping so much easier. And with the options I've given myself for mounting, I've basically removed any tooling limitations I might run into. I'll definitely be using this tool a lot in the future, which after the roller coaster I just went through, makes it all worth it. I certainly didn't think I would have any issues on such a straightforward project, but at least with each mistake, there was a valuable lesson to be learned. Especially the biggest lesson of all. Never, ever get complacent. As always, thanks for watching, and see you next time.